Hi, so we're going to be talking about our UML and implementation design for the Hero Lab. And for this lab, we're basically working with like this video game company, World of Heroes. And so for this video game, they want to create a hero, and these heroes are going to have a race and a job, and they're going to be able to attack other heroes within this game. So these race and jobs influence what their attack power is going to be. And so our program is basically generating these heroes and spitting out what their attack value is going to be so that it can be used by video game developers later down the line. And now I'll pass it off to Chandra to talk about our UML.
So first off, we wanted to construct our hero class. And our hero class is going to be constructed through our hero factory, which takes in the string of race and job and makes it into the hero itself. So we create the hero through the hero factory, and it's then referenced to the hero class. And from hero class, we make an implementation or with an interface, with hero interface specifically, to make sure that we grab all the details that we need to further break down hero class into both the job and a race split. And so hero class is gonna have two compositions, one being job interface and race interface, and those are gonna grab different data, whether job interface is gonna grab the attack, which is gonna grab, which is also gonna reference our value, our strength, our dexterity, and intelligence, as well as the job name. And then our race interface is going to grab our strength, our dexterity, and intelligence of the race name that's being implemented, because each race has different types of data stored within them, and we're really returning the values immediately rather than just storing it all as integers. And so we make individual classes that pull from the race interface and the job interface, whether they are elf, dwarf, robot for the race, and then our jobs will be warrior, mage, archer. Maybe soon there'll be more classes, but for now, this is the best case scenario for implementing multiple classes. And so we pull elf, which calls in elf itself, the strength, the dexterity, and intelligence. And elf will have a bonus of +5 in dexterity, while also making sure to get the race name. And then dwarf and robot have bonus stats. And warrior, and I mean job specifically, job string will be able to intake a value and also construct its attack by its attack bonus, I guess you could say. Each attack value is different in each job, whether warriors having like strength times dexterity plus value, right?
Mm-hmm.
And each value is just having different attack methods in order to result in their attack value. And all of this is being referenced back into the hero class. So that's why we're able to use our hero interface to make sure that we are getting strength, getting dexterity, getting intelligence, getting race name, and getting job name, and the attack. All these values are being referenced to our interface. And that's what we call an interface polymorphism, where we are able to just make a promise, I guess you could say, making a statement between the hero class that says, hey, I will assign you to job, and this job does this certain criteria, and it comes back into the main function as a whole. So that's why we're able to use these interfaces and break it down to classes such as warrior, mage, and archer in order to get back into the hero function itself.
And we can see this composition in our UML with the attributes of our hero class. We have a protected race interface race and protected race job interface job. So this kind of allows us to not even need if statements. That'll slow down our code, because all of the classes for the jobs and races like elf, dwarf, mage, and so on are all going to know which race object or which job object is being passed to them. So we don't need to say, if they input a warrior, go to the warrior class. It's going to have a job is going to be set equal to the object of warrior.
And we're able to just use warrior to call back, and just in case if our Hero class is calling for the job interface hero no, warrior, and then that's able to do all the processing, similar with race.
So for future implementation of adding more jobs and more races, you could simply just create another class. If you had a race of, I don't know, giant or something like that, you create a race giant, implement the race interface, and it'd basically be like the exact same kind of code and follow the same structure as everything else. So it's fairly adaptable to the customer being able to add their own races and jobs into the program. There was another constraint of which we had to use ints for all of our numbers. We ran into a small problem with the Archer class of it having to divide times by 1.5. We kind of circumvented this by multiplying by 2 and dividing everything by 2 to kind of fix that error. If I said that correctly, right?
So to be specific, we replaced 1.5 by 3 and just divided it by 2 in order to just get rid of the 1.5, because that would shoot into like more like providing decimals, and integers cannot intake decimals. So we're able to just change the value instead of 1.5 in Archer to 3 and then divide the whole thing by 2.
Yes, thank you for that. And I believe that's everything that we have.
I believe so.
All right.
Hope you guys enjoyed. Make sure to subscribe, hit the like button, and
smash that like button down below.
Smash the like button down below.
Bye.
Thank you so much.
Wait, I didn't stop recording. Crap.